Welcome back, everyone, to another reaction video. Well, 39 years ago today is a day that I will never forget. I wasn't very old. I was only 8.5, but I remember vividly the events of January 28th, 1986, especially because of how it all went down. And I'm talking, of course, about the Space Shuttle Challenger explosion. What was unique about this particular event in the history of the United States is that millions of school children watched it happen live, because there had been this whole thing to kind of get people reinterested in the space program. So they did a contest where they were going to put a civilian, a teacher in space, and that teacher, whoever won the contest, they were going to train like all the other astronauts. And then they were going to go into space, and they were going to broadcast lessons for school children from this teacher back down to Earth. And so these are the days before, all the AV equipment that we have in auditoriums now. So a lot of schools just wheeled a TV into the auditorium and brought all their students down and watched the launch of the Challenger live, and then watched in horror as it exploded just a little over a minute after takeoff, and eventually killed the 7 astronauts that were on board. So a lot I remember about that day, and I'll talk more about my memories of that day as we get into this video. But we're going to take a look at the infographics show because they have a video that came out last year called The Challenger Space Shuttle Disaster Explained Minute by Minute. So we're going to talk technically, I guess, about what exactly went wrong. I think a lot of people know the basics, but maybe don't know the details. And this will give us an opportunity then to talk a little bit more about what went down. And I can share some of my memories from that day because it's one of those events I will never, ever forget. The link is in the description to the original content, so you can check it out without my commentary. Let's dive into this one.
73 seconds after launch, the Challenger space shuttle rises higher and higher towards space. Its iconic white solid rocket boosters roar as flames spew out of the back of them. The flight crew has continued to communicate with launch control since liftoff. No one knows that anything is wrong and that in the next second, tragedy will strike. A fire rages along the side of the right booster as fuel escapes due to a compromised seal. In moments, the supporting struts connecting the rockets to the orange external fuel tank will experience a catastrophic failure. The booster will slam into the tank, rocket fuel will ignite, and there will be a massive explosion. April 4th, 1983. T-minus 2 years and 9 months until the Challenger disaster. All systems go, prepare for liftoff. Mission Control says over the intercom to the Challenger flight crew, this will be the space shuttle's maiden voyage. The boosters ignite, and the 184-foot, 4.5 million pound space shuttle thrusts towards space.
Yeah, and so there were several space shuttles, and these were a big deal because these were reusable. I mean, standard now that we reuse our rockets, like SpaceX and Blue Origin and those things. They reuse the rockets, but even then the shuttle was reusable, but the rest of that was like a one-time use thing. But to have a reusable shuttle instead of having to make a new one every time, it made spaceflight more regular, and we'll end up having Columbia and Discovery, Atlanta. I think Discovery is actually the one that replaces Challenger, and you had Atlantis. And then I think there was Enterprise, but I don't know if that one ever actually went into space. I think that was like a test one or something.
First mission was a success, and the Challenger space shuttle will end up flying 6 more missions that year. The shuttle is reliable, but every time it launches into space and lands after re-entry, a toll is taken on the spacecraft. Constant repairs need to be made while old components are swapped out for new ones. Engineers who work on the shuttle day in and day out warn NASA that the stresses that constant missions to space place on the space shuttle may lead to tragedy in the future. July 19, 1985, T-minus 6 months until the Challenger disaster. We're pleased to inform you that you've been selected to become the first teacher to go to space. Krista McAuliffe can't believe the words she's just read. Several months ago, she submitted her application to the NASA Teacher in Space project along with 11,000 other educators.
Think about that. 11,000 people applied for this, and you are over the moon at the fact that you are the one that gets selected, having no idea that by winning this contest, the clock is ticking on the end of your life. It's horrible to consider, but At the time, she was on top of the world, as you would expect to be.
Never in her wildest dreams did she believe she would be chosen. However, this letter confirms that she will in fact be going to space and that she will be lucky enough to share this incredible experience with students across the country when she gets back. McAuliffe teaches at Concord High School in New Hampshire. When she tells her colleagues the news, they are elated. Her family, friends, and students are all extremely happy for her. As a part of the Teacher in Space project, she will conduct 2 lessons from orbit and embark on a lecture series across the United States to share her experience with students. This will be done to highlight the importance of teachers in the country and hopefully inspire students to pursue careers in technology and science.
And again, like I said, this is a time when you don't have the space race anymore. There's not this great competition between the United States and the Soviet Union to make it to the moon and to do these kinds of things. So you need to do something to keep people interested and keep people excited about the space program because it's becoming routine. Yeah, we had deaths one time. It was Apollo 1, and those were 3 deaths that happened on the ground during kind of a training exercise that was going on. Nobody's ever, at least for the United States, nobody's ever died in space flight before. So it's become routine, and people aren't really considering that this is still a really dangerous thing that we're doing.
Over the next several months, McAuliffe joins her fellow crewmates at Johnson Space Center in Houston, Texas, where they train and prepare for their coming mission.
Arlington.
Francis R. Scobie will be the commander of the spacecraft. In April of 1984, he piloted Challenger mission STS-41C, which deployed a new satellite and repaired a damaged satellite before returning to Earth. Since then, he's been an instructor pilot for the Shuttle 747 carrier aircraft. This will be his first space command, and he couldn't be more excited. Piloting the mission will be Michael J. Smith. He's flown 28 different types of civilian and military aircraft and logged 4,867 hours of flight time.
Now, here's the thing about the space shuttle, though. It's less airplane and more glider. It's a big giant brick with wings. So when you're landing it, it doesn't have like powered flight to where you can really do a whole lot except just glide it to the landing zone and hope that you get there.
Judith A. Resnick will be one of the mission specialists on board. Resnick had become part of Astronaut Group 8, which was the first to include women on the team. She's developed a variety of software and procedures that are utilized throughout NASA. She's been to space before aboard the STS-41D mission in August 1984. This was the very first mission of the Space Shuttle Discovery. 2 other mission specialists are a part of the Challenger crew as well. Ronald E. McNair flew aboard Challenger in February 1984 during mission STS-41B. It was on this mission that he became the second African American to fly into space. Ellison S. Onizuka was the first Asian American and the first person of Japanese origin to reach space during his time aboard the Space Shuttle Discovery during STS-51C.
Everybody remembers Krista McAuliffe because of the teacher thing. It's what made this one unique, but this is a remarkable group of people. These are all people that have risen to the top on the merits and on their abilities and have really set the standard. And you know, we shouldn't let that go by, recognizing what remarkable people all 7 of them were.
The final crew member aboard the upcoming Challenger launch, designated STS-51L, is Gregory B. Jarvis. He's the payload specialist. This will be his first time in space, although he's been slated to fly aboard a different shuttle in April of 1985, but his spot was given to U.S. Senator Jake Garn instead. Then a similar situation happened again in early January 1986 when U.S. Representative Bill Nelson took his place aboard another space shuttle. Now Jarvis finally has the opportunity to reach space where he can put his astronaut training to good use.
And again, Jarvis would have been on one of those other ones. He's probably then not on the Challenger and someone else is. Someone else dies instead of him. Well, I'm thinking about it too. I said earlier about the shuttle that replaced Challenger. It was actually Endeavour was the one that replaced Challenger.
But like every other member of the crew, he will never actually make it beyond Earth's atmosphere. January 22nd, 1986, T-minus 6 days until the Challenger disaster. The Challenger crew eagerly awaits confirmation of whether their mission is a go or not. A high-ranking NASA officer enters the room with a frown on his face. "Sorry about this, crew, but we're gonna have to delay your mission until 61C gets back. Their assignment ran into delays, and their shuttle isn't due to land until tomorrow." The Challenger crew looks at one another in dismay. They're eager to get going. Every mission to space is special, and even for veteran astronauts, it's what they dream about doing every night. It's as if the stars are beckoning them to reach for the unknown. January 26th.
It really does take kind of a special mindset and a special kind of person to want to do something like this. I mean, a lot of us would be like, yeah, it'd be cool to go to space, but it's a difference between saying, oh, it'd be really cool to do that, and putting in the work and the effort and having the drive to rise to the top of your field to be able to get to that place where you beat out probably thousands of other people who want to be a part of the astronaut program.
7th, 1986, T-minus 1 day until the Challenger disaster. Challenger mission STS-51L is planned to have an early morning liftoff the following day. The astronauts toss and turn in their beds in anticipation. A chill sweeps across Florida as if foreshadowing the ominous events that'll happen in the coming hours. The launch pad becomes covered in thick ice. The metals that make up the space shuttle and boosters contract slightly with the cold. As engineers check the spacecraft over and over again to make sure it's in an acceptable condition for launch, a disturbing realization surfaces. "Sir, I want to reiterate that I'm concerned about the reliability of the seals in the rockets," an engineer explains to his supervisor. For over 2 years, the engineers and technicians that work in the shuttle program have warned that the space shuttles are being overused. The crafts are sturdy and well made, but every machine has its breaking point, and it feels as if after dozens of flights, it's only a matter of time before something tragic happens.
Yeah, but here's the thing. I don't think, and I'm sure we'll get into it, I don't think it was the shuttle itself that had the failure. That was true with Columbia, which is going to happen nearly 2 decades later. That was an actual failure on re-entry that was on the wing of the shuttle itself. And that only happened because of a piece of debris that fell and broke and hit it. But I think it was on one of the boosters on the side. It was the O-ring that actually goes bad.
The NASA official acknowledges the engineer's concern, but does nothing more. The launch will commence as scheduled, regardless of the warnings voiced by the men and women working directly with the spacecraft. January 28, 1986, 9 a.m., T-minus 2 hours and 38 minutes until the Challenger disaster. The sun is rising higher and higher over the Atlantic Ocean. A crowd gathers around Cape Canaveral to watch the launch at Kennedy Space Center, scheduled for later that morning. There are members of the press, local residents, and people who have traveled from around the world to watch the launch. Many are there to witness the historic event of the first teacher to go to space. Excitement and anticipation fill the air. This will be the 25th Space Shuttle launch and the 10th Challenger mission.
And 24 for 24 on the launches, right? I mean, it's had a perfect success rate. And there's so many things that can go wrong with spaceflight.
Other flights have been successful, so there's no reason to suspect today should be any different. The astronauts don their suits and proceed to their launch vehicle. They are greeted by cheers as they step off their transport and proceed toward the elevator that will carry them to the cockpit of the Challenger. Mission Control in Houston prepares to track and monitor the space shuttle's progress. Telemetry coming in from hundreds of sensors is recorded and double-checked to make sure that Challenger is ready. The astronauts strap in, and the shuttle door is sealed behind them. The cockpit is quiet except for the sounds of switches being engaged while Scobie and Smith check the systems on board. There's a sense of anxiousness, excitement, and pride as the 7-person crew prepares for launch. McAuliffe looks out the window directly ahead of her at the blue sky. Just beyond the atmosphere lies the edge of space. A bird flies past. McAuliffe smiles. Soon she'll be doing something that only a handful of people in all of history have done. She checks her safety harness and leans back in her seat, releasing a long sigh. Besides the crew, the shuttle also carries a tracking and data relay satellite designated TDRS-B. Also in the cargo bay is the Spartan Halley aircraft, which is designed to be released from Challenger to study Halley's comet for 2 days while the celestial object approaches the sun. The small satellite will then be picked up by the Challenger crew and brought back to Earth so scientists can analyze the data it's collected. Tragically, no one and nothing aboard Challenger will survive to perform this series of tests. January 28, 1986, 11:38 a.m., T-minus 10 seconds until launch. Due to weather conditions, the launch has been delayed yet again. However, the atmosphere is beginning to cooperate. The sky clears up and the wind calms. Commander Scobie and Pilot Smith check their sensors and instruments one last time as they prepare for the rockets to fire. Mission Control reaches the end of its countdown. 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1. And liftoff. Moments before the engines ignite and the space shuttle rises, the solid rocket ignition command is sent. The boosters roar to life. The space shuttle and the Earth around the launch pad begin to shake. The sound travels across the water and reaches the bystanders watching the space shuttle launch from miles away. Astronaut Judy Resnick is heard over the intercom. "All right," she yells. Challenger space shuttle achieves liftoff. After the rockets ignite, 8 25-inch long, 7-inch wide exploding bolts fire. The Challenger space shuttle is free to rise into the sky. The deafening boom of the engines, massive amounts of smoke, and intense heat roll across the launch pad. A quarter of a second after launch, sensors record the first vertical motion of Challenger as it begins its ascent. Unknown to anyone on board or at mission control, an abnormal black smoke is seeping out of the right solid rocket booster near the location of one of the O-ring joints.
So this goes to show you that this was a problem that was there before launch. It wasn't something that developed. You know, like when Columbia broke up on re-entry, that was the result of something that happened during takeoff. It wasn't the result of something that had failed before. Well, maybe it was, but something falls off and it hits the wing and it causes damage. In this case, it was something, I don't know if it was something that could have been found, but it was obviously there.
This is the first sign that something is about to go terribly wrong. 1 second after liftoff. "Here we go," pilot Michael Smith says over the intercom. As the space shuttle proceeds toward the heavens, the black smoke coming from the right rocket seems to be slowing down. 3 seconds after liftoff, Launch Commander Hugh Harris has just finished the countdown and pauses for a moment to watch. He announces on NASA Select Television, liftoff of the 25th Space Shuttle mission, and it has cleared the tower. The abnormal black smoke coming from the bottom of the solid rocket booster appears to have disappeared completely. 5 seconds after liftoff. All systems go. There are no anomalies detected by anyone at this point in the launch. The 3 liquid-fueled main engines on the back of the space shuttle are throttled up from 90% to 104% thrust. Everything is going according to plan. At Mission Control, Data Processing Systems Engineer A.F. Elgate confirms liftoff. There's a cheer in the room, then everyone immediately goes back to monitoring their stations.
So all I can think about is, I mean, every one of these stations and every one of these people involved, there's data that's being collected every second. And then after this goes horribly wrong, at just after 70 seconds, they're going to go back and they're going to watch this frame by frame. That's why they're going to notice the smoke. And they're going to start to see all these little things. And, you know, hindsight is 20/20. But it all happened so fast. Remember, from liftoff to explosion, we're talking just over a minute.
Suddenly, there's a data blackout from the space shuttle. No one panics. This is to be expected as the flames and structures around the launch complex interfere with the radio signals being sent to the antenna complex. But there is one piece of data that is slightly unnerving. I'm reading the internal pressure on the right side booster to be 11.8 pounds per square inch higher than normal, one of the technicians in Mission Control says.
And here's the thing, you know, if you do see something that is not only abnormal but is potentially catastrophic, there's not a ton you can do about it. They've already taken off. There's not a lot to be done. I mean, maybe you drop the right side boosters and you go into an abort.
Rocket is still within acceptable parameters, but this initial data point will be used later on to identify when the Challenger space shuttle began to run into trouble. 8 seconds after liftoff. Once Challenger is in the open air, Pilot Smith begins a roll maneuver that puts the crew in a heads-down position so the top of the space shuttle is pointing toward the Earth and the bright orange external fuel tank is toward the sky. "Houston, Challenger, roll program," Commander Scobie says over the intercom. "Roger, roll Challenger." Astronaut Dick Covey says from Mission Control. "Good roll, flight." Flight Dynamics Officer Brian Perry confirms from the control room. 19 seconds after liftoff. The Challenger space shuttle begins to shake. There's a sudden, violent thrust to the side. The crew grits their teeth as Michael Smith pulls on the flight stick slightly. With the help of the nav system, the space shuttle realigns itself, and Challenger is back on course.
You ever been on an airplane and you hit some bad turbulence? You know, for those of us who fly a lot, you know, not a big deal. But sometimes you hit turbulence that even has me kind of like, oh, okay, that was a bit much. You can only imagine. Especially if it's your first space flight, you hit a little bump like that, and your mind's probably wondering, is this normal, or is this really, really bad?
"Looks like we got a lot of wind here today," says Smith over the intercom. Commander Scobie confirms the assessment. They begin throttling down the 3 main engines of the space shuttle to 94% thrust as planned at this point in the flight. 21 seconds after liftoff. Challenger's roll maneuver is completed and all systems confirm it is on the proper trajectory to reach orbit. Commander Scobie looks out the cockpit window, hoping to get a glimpse of the land below. "It's a little hard to see out my window here," he says. The engines continue to throttle down. 28 seconds after liftoff. "There's 10,000 feet and Mach 0.5, Smith says over the intercom. Challenger is now traveling at half the speed of sound and is 10,000 feet above the surface of the planet. It's at this point that the space shuttle begins reaching the region of maximum aerodynamic pressure. Mission Control confirms that engines are throttling down to 94% and remind the flight crew that they will be throttling down to 65% thrust in a few seconds.
So a couple of things going on. Listen, I'm no space engineer or anything like that, but when you first take off, that's your moment of maximum mass and maximum weight, right? Because you have all of the fuel that you need to get to space. So every second you fly, your vehicle's getting lighter and lighter because you're burning fuel. And you're also getting to thinner and thinner air where it doesn't require as much to kind of work against that. And so you don't need as much thrust at 10,000, 15, 20,000 feet as you did at takeoff.
35 seconds after liftoff, Smith begins to throttle down the engine some more. All data indicates that the shuttle's computer systems are making the proper adjustments to deal with the wind shear. 5 seconds later, Smith confirms that they have reached Mach 1. Scobie adds they're passing 19,000 feet in altitude. 45 seconds after liftoff. There's a bright flash slightly behind the space shuttle's right wing. Moments later, there's a second bright flash. 48 seconds after liftoff. A third flash appears downstream of Challenger's right wing. The crew can't see these ominous explosions, but a 70mm tracking camera captures them as it zooms in on the shuttle for a close-up view. Everyone who is viewing the footage is baffled at what they're witnessing. Suddenly, an orange ball of flames erupts from under the right wing. This fireball is coming from the right booster. The Challenger crew and Mission Control have no idea that anything is wrong, as the space shuttle's telemetry all reads nominal. The fireball from under the wing merges with the flames of the solid rocket boosters. 58 seconds after liftoff. Challenger accelerates past 1,539 miles per hour, or 2,477 kilometers per hour. It has an altitude of 26,127 feet, or 7,963.5 meters. Scobie gives the command to throttle the engines back as planned. Smith confirms the command. Mission Control confirms that the 3 engines of the space shuttle have all throttled down to 65% thrust. While this is happening, the tracking camera on the ground observes the first evidence that there is now something seriously wrong with the right solid rocket booster. An abnormal plume of smoke has begun pouring out of the rocket. The Challenger crew has no sensors in the cockpit that display the performance of the solid rocket boosters,
no idea.
And therefore are unaware that they are in serious danger. A second later, Challenger passes through the region of maximum aerodynamic pressure, which pushes against the space shuttle and its boosters with 720 pounds of pressure per square foot.
So this is the greatest amount of stress on the craft, and this is where it's going to just be too much. And then when they throttle up, that's it. But, keep in mind that we're 14 minutes into this video now. All of this is happening in 1 minute from takeoff until explosion. Just over a minute.
7,750 pounds per square meter. The plume of smoke coming from the side of the booster intensifies. Inside the booster itself, an O-ring has disintegrated, the very same component that engineers at NASA were warning would fail if the space shuttle launches were not dialed back.
So I need to check on this because those O-rings are in those solid rocket boosters on the side. Are those reused? Because I know the shuttle's reused. Okay, so the answer is yes. I did check on that, and so they'd be released. They're recovered at sea, and then they're disassembled and reassembled to be reused. And so these are parts that are being used over and over again. Now, whether the O-rings are new each time when they reassemble them, I don't know.
Ring on the booster was meant to seal the joints between separate parts of the rocket and prevent the leaking of fluids and gases from one chamber to another. With the O-ring destroyed, fuel is making its way through the booster and igniting due to the intense heat of the flames. A continuous inferno is expelled from the right booster along the side furthest away from the space shuttle. The windows in the cockpit give Scobie and Smith limited visibility, and they're not able to see the fire from the shuttle. 60 seconds after liftoff. "Feel that mother go," Smith says over the intercom. Another member of the crew is heard yelling with joy in the background. At that moment, Mission Control receives data that indicates the internal pressure in the right side solid rocket booster has begun to drop. It's not known at the time, but this severe drop in pressure is the result of the hole created by the ignited fuel spewing out the side of the rocket where the O-ring has failed.
This is all
The
happening
flames
so
pouring
fast.
out of the side of the rocket begin to lick the fitting attachments that couple the back end of the booster to the external fuel tank on the underside of the space shuttle. This starts to degrade the integrity of the couplings. 62 seconds after liftoff, Challenger shudders once again from high wind speeds. The shuttle rolls slightly to compensate as it passes 35,000 feet and approaches Mach 1.5. The wind is worse than predicted and stronger than any of the previous 24 shuttle missions. However, it's still within acceptable limits, even if it puts slightly more stress on the shuttle. 64 seconds after liftoff, the flame in the right side booster changes shape suddenly as the heat from the fire melts through metal plating, and liquid hydrogen begins
So
to...
I'm a little confused, and maybe it's just a mistake here, because they said earlier they were going 1,500 miles an hour, which is already, that's pretty much Mach 2. And now he's saying they're approaching Mach 1.5, which would only be about 1,150 miles an hour. So I don't know if that's a mistake on his part or if they actually slowed down.
To fuel the fire.
Possible.
The glow on the outside of the booster intensifies. As the force of the raging fire builds up, it begins to move the engine nozzle in large arcs. This momentum begins to shift the space shuttle's course, which the computer then adjusts for. The right booster's thrust levels are thrown off due to the leaking fuel and fire burning on the side. However, the nav system manages to compensate. Tremors vibrate through the cockpit as the hydrogen fuel is ignited, but get lost in the turbulence experienced due to the massive acceleration and wind shear. 66 seconds after liftoff. Throttle up, 3 at 104, Mission Control says over the comm. Houston and the Challenger flight crew are all still unaware of the fire coming out of the middle of the right booster.
And this is the thing that I always remember about that day is they say go for throttle up, and like that's like the last communication before the explosion.
Other than a drop in pressure, there's no indication that there is a serious problem. The fire outside of the shuttle spread further. The flames creep toward the belly of the shuttle, where the external liquid hydrogen tank is located. The pressure inside the fuel tank suddenly begins to drop, indicating that an alarming amount of liquid hydrogen is leaking out. The fuel tank gauge plummets inside the cockpit, but Smith and Scobie don't notice it as they're focused on throttling up the engines and preparing to disengage the boosters. Even if either crew member was looking at the fuel gauge, the rapid dropping of pressure happened so quickly that there was nothing they could have done.
Nothing.
The fuel tank can only be disengaged when all other engines are turned off, and
The only way in all of this that anything could have been done is if there was a way for them to disengage the orbiter from the rest, or even if there was some kind of system, as we're going to see, for the crew compartment of this to have parachutes or something. Because they survived the explosion. That's the really tragic part in all this. Is as horrible as this was, the fact that they were alive when they hit the water is the most horrible.
shuttle is in a benign aerodynamic environment higher up in the atmosphere. If they had disengaged the fuel tank to get away from the leak at this stage, the Challenger would have been forced into the fuel tank and the still burning solid rocket booster exhaust. 68 seconds after liftoff, the fire spewing from the side of the rocket connects to the exhaust plume. The liquid oxygen propellant being fed into the main engines of the space shuttle falls drastically. Smith continues to throttle up the engines to reach 104% thrust. 72 seconds after liftoff, the back end of the right booster is ripped away from the external fuel tank. The strut that had been securing it has been compromised and failed. The back end of the right booster is now moving up and down relative to the space shuttle and fuel tank. Another explosion, likely from the stress and leaking fuel, occurs higher up on the booster near Challenger's cabin. The flame near the top of the booster grows rapidly, creating an enormous fireball. The nozzles of the engines on the back of the space shuttle begin moving at a rate of 5 feet per second in order to compensate for the unhinged booster. The top of the right booster is still connected to the fuel tank, but the loose back end causes a burst of lateral acceleration that jerks the shuttle. The main engine pressure decreases. Engine nozzle motion rates are off the chart. Things are very, very bad. Challenger sends its final navigation update. 73 seconds after liftoff. "Uh-oh," Smith says. These will be the last words uttered over the comms by any of the Challenger crew. It's not clear what Smith is referring to, but it's likely that several sensors begin showing clear signs that something is wrong. The fuel tank and loose booster begin breaking apart. The shuttle jerks the opposite way it had moments before. The right booster is now producing 100,000 pounds of thrust less than the left booster. The unbalanced acceleration begins forcing the right booster up into the liquid oxygen section of the external fuel tank. Liquid hydrogen and oxygen begin leaking out of the external tank. A cloud of fuel accumulates outside. The right booster pushes further into the fuel tank and increases the amount of liquid oxygen being expelled.
This is all fractions of a second at this point that this stuff is happening.
Seconds later, the inevitable happens. There's a bright flash of light located between the Challenger shuttle and the external fuel tank. The leaking fuel has been ignited. The fireball engulfs the space shuttle. There's a crackling sound over the intercom as ground transmitters search for a signal that is no longer there. Another explosion occurs near the front of the external fuel tank. This ignites the remainder of the fuel inside the front section of the tank, causing it to detonate. Challenger's engines redline and the computer initiates an emergency shutdown. Main engine 3 goes first, followed by number 1. The last telemetry signal from the space shuttle is sent while it is being torn apart. 74 seconds after liftoff, the radio signal from Challenger goes silent. Another explosion occurs near the space shuttle's nose. The cockpit with all 7 members of the crew is engulfed in flames as the rocket fuel in the forward reaction control system ignites. The debris of the destroyed shuttle continues traveling upward at Mach 1.92, or approximately twice the speed of sound. It reaches an altitude of 46,000 feet or 14,021 meters. Challenger's tail emerges from the fireball around the same moment that a wing can be seen. The fuselage and payload bay are torn apart by the rush of air forced in from the tail being ripped off, overpressurizing the payload bay and breaking it apart from the inside out. Wires and electrical cables flail behind the fuselage like tentacles.
All I can think about are the families of those astronauts who are on the ground there watching this happen live. And you know something has gone horribly wrong. And you know that when it comes to things going horribly wrong in spaceflight, there aren't a lot of options for survival. And so you're processing what you're seeing and trying in your mind to find some way in which it's possible that they're alive in all of this.
Satellites in the cargo bay are ejected into the air. The crew cabin arcs out of the flames and smoke. It seems to be intact, although there's a gaping hole where it used to be connected to the rest of the shuttle. Some of the crew may still be alive and awake, but when the Challenger is ripped apart, all of the air is sucked out of the cockpit, and a dramatic pressure drop results in everyone passing out. For this mission, the astronauts did not wear pressurized suits during liftoff. As they slump in their seats unconscious, oxygen deprivation settles in. Any crew member who is still alive will suffocate within the next few minutes. The 2 solid rocket boosters continue to fly upward at different angles, now free.
My understanding is that, they're at 40,000 feet. I don't know what terminal velocity would be for the crew compartment, but terminal velocity for a person is about 120 miles an hour. So how quickly are they going to get down to 10, 15,000 feet where it's breathable air? I'm hoping they didn't wake back up before they hit.
Free from the struts that connected them to the external fuel tank. 1 second after the Challenger space shuttle explodes. Mission Control does not yet know that the Challenger space shuttle has exploded. 1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 7 nautical miles, says Stephen Nesbitt, the public affairs officer at Mission Control. 2 seconds after the Challenger space shuttle explodes. A parachute emerges from the carnage, giving people hope. But as the tracking camera focuses, it turns out to be the nose cap of the right solid rocket booster. Smoke and flaming debris arc outward from the blast. The rocket boosters continue to fly upward, leaving a corkscrew trail of smoke behind them. 15 seconds after the Challenger space shuttle explodes. Flight GC, we've had negative contact, loss of downlink, says the ground control engineer N.R. Talbot. It's at this point that Mission Control is aware something tragic has happened and is trying to figure out exactly what happened. They're informed that the Challenger space shuttle has been lost. 36 seconds after the Challenger space shuttle explodes, a self-destruct signal is sent to the rogue solid rocket boosters, triggering an emergency detonation. Both rockets explode in a plume of black smoke. Debris falls back toward the Earth. Without the weight of the space shuttle and the fuel tank, there was no telling how far the rockets would have gone before burning the last of their fuel. They needed to be detonated to eliminate the risk of them crashing back to Earth in a populated area rather than the desolate waters of the Atlantic Ocean. 1 minute and 31 seconds after the Challenger space shuttle explodes. Multiple sources have now confirmed that the Challenger STS-51L has been lost. Rescue efforts are launched. 2 minutes and 11 seconds after the Challenger space shuttle explodes, the TV tracking camera spots the first pieces of the space shuttle crashing into the ocean. 33 seconds later, the crew cabin slams into the waves of the Atlantic at approximately 200 miles per hour.
Okay, so it is falling faster than terminal velocity for people, but you're still talking 2 minutes. So, yeah, when he said that they would suffocate within the next few minutes, they're not in the oxygen-free environment long enough to suffocate, I don't think. Hopefully they're unconscious, but my understanding is that at least some of them were alive when they hit the water.
322 kilometers per hour. At a braking force 200 times that of normal gravity,
killed them.
The crew cabin disintegrates on impact and sinks 100 feet to the bottom of the ocean. For the next few minutes, debris continues to splash down into the ocean east of Patrick Air Force Base. A cloud of brown smoke lingers over the surface of the water as a result of the hydrazine rocket fuel that covered the wreckage as it entered the ocean. Mission Control pinpoints the crash site as being approximately 28.64 degrees north at 80.28 degrees west, 5 minutes after the Challenger space shuttle explodes. The broadcast on NASA television has been eerily quiet as everyone tries to take in what just happened. The camera view switches from the ocean back to the grandstand at the press site. Observers stand with their backs to the camera, looking up at the sky where a white cloud of smoke still lingers. White wisps of haze extend from the explosion site, like weeping willow vines indicating where burning debris fell from the sky. 8 minutes and 5 seconds after the Challenger space shuttle explodes. This is Mission Control, Houston. We are coordinating with recovery forces in the field. Range safety equipment, recovery vehicles intended for the recovery of the SRBs in the general area.
Yeah, so these are the vehicles that are there to recover those two side boosters when they hit the water. So they kind of anticipate where they're going to be, so they've got stuff in the area already. Hopefully they haven't been hit by any of the falling debris.
Stephen Nesbitt in a somber voice. The only thing left to do is go through the data, recover as much of the space shuttle as possible, and determine what caused the horrific accident that led to the loss of 7 people aboard the Challenger space shuttle. March 7, 1986, 1 month and 10 days after the Challenger space shuttle disaster. The USS Preserver bobs up and down in the dark waters of the Atlantic Ocean. A dive team has just been deployed to scout the hypothesized location of the Challenger cabin. The divers locate the wreckage that was in the front of the space shuttle and confirm that the bodies of the crew are still inside. The aftermath of the Challenger space shuttle disaster. All space shuttles are immediately grounded, and any upcoming launches are canceled, pending a full investigation of what happened to the Challenger. NASA and a group of men appointed by President Ronald Reagan, known as the Rogers Commission, began looking into the chain of events that led to the loss of the space shuttle and its crew.
So I want to stop right here. I know we've only got a couple of minutes left, but before we get too much into the aftermath, I want to talk about that day because understand, as I said at the beginning, that you're dealing with hundreds of thousands, if not millions, of school children who knew that there was a teacher going up in space, and for whom many of these kids, your teachers are your heroes. These are people you look up to, that you see every day, and one of them has just died right in front of your eyes. So Ronald Reagan, and I understand that we're talking about a political figure, and so people have very strong opinions about him and his politics. I'm not talking about his politics right now. Ronald Reagan, by profession, had been an actor before he went into politics. He was governor of California, and then he's president of the United States. And so he's often referred to as the great communicator because he was natural in front of a screen. It was what he did for most of his adult life. And he gave that evening a speech that I, as an 8.5-year-old kid, was so impressed by. And whatever else people may say about Ronald Reagan or think about him, in that moment, I was in awe of that speech. To me, to this day, having watched these events unfold, best presidential speech I've ever experienced. And I want to show just a little clip of it. We might actually watch the whole thing. It's just under 5 minutes long. But I want you to put yourself in the mindset of an 8-year-old kid like me, watching everything that happened that day and feeling everything you would have been feeling that evening and wondering what the president's going to say about it.
Ladies and gentlemen, I'd planned to speak to you tonight to report on the State of the Union. The events of earlier today have led me to change those plans. Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger. We know we share this pain with all of the people of our country. This is truly a national loss. 19 years ago, almost to the day, we lost 3 astronauts in a terrible accident on the ground. But we've never lost an astronaut in flight. We've never had a tragedy like this. And perhaps we've forgotten the courage it took for the crew of the shuttle. But they, the Challenger 7, were aware of the dangers, but overcame them and did their jobs brilliantly. We mourn 7 heroes: Michael Smith, Dick Scobie, Judith Resnick, Ronald McNair, Ellison Onizuka, Gregory Jarvis, and Krista Mikaloff.
It's a couple things just right there in just that moment. First of all, he builds them up as heroes. He reminds people that this is dangerous stuff they did. He reminds people they were doing their jobs and they did their jobs well. Don't go blaming the astronauts. Don't go saying that they screwed up and naming every one of them by name. All good stuff.
We mourn their loss as a nation together. The families of the 7, we cannot bear, as you do, the full impact of this tragedy. But we feel the loss, and we're thinking about you so very much. Your loved ones were daring and brave, and they had that special grace, that special spirit that says, give me a challenge, and I'll meet it with joy. They had a hunger to explore the universe and discover its truths. They wished to serve, and they did. They served all of us. We've grown used to wonders in this century. It's hard to dazzle us. But for 25 years, the United States space program has been doing just that.
So now we're going to talk about NASA and its importance. And a lot of this is about, it sounds insensitive to say it this way, but this is PR. This is spin control. This is look at our program. We do it all out in the open, and we have no secrets when it comes to our space program, and we should be in awe of what they've accomplished.
We've grown used to the idea of space, and perhaps we forget that we've only just begun. We're still pioneers. They, the members of the Challenger crew, were pioneers. And I want to say something to the school children of America who were watching the live coverage of the shuttle's takeoff. I know it's hard to understand, but sometimes painful things like this happen. It's all part of the process of exploration and discovery. It's all part of taking a chance and expanding man's horizons. The future doesn't belong to the faint-hearted. It belongs to the brave.
You can see me tearing up a little bit about that, because when I see this, I'm still that 8-year-old kid watching that. And it's just remarkable. It really was.
Your crew was pulling us into the future, and we'll continue to follow them. I've always had great faith in and respect for our space program, and what happened today does nothing to diminish it. We don't hide our space program. We don't keep secrets and cover things up.
Remember, this is the height of the Cold War. This is Reagan and Gorbachev. This is right at the beginning of when you're going to have Gorbachev, but the Soviet Union, and this is distancing America from the Soviets and how we handle tragedy.
We do it all up front and in public. That's the way freedom is, and we wouldn't change it for a minute. We'll continue our quest in space. There will be more shuttle flights and more shuttle crews, and yes, more volunteers, more civilians, more teachers in space. Nothing ends here. Our hopes and our journeys continue.
That was important, too.
I want to add that I wish I could talk to every man and woman who works for NASA or who worked on this mission and tell them your dedication and professionalism have moved and impressed us for decades, and we know of your anguish. We share it. There's a coincidence today. On this day, 390 years ago, the great explorer Sir Francis Drake died aboard ship off the coast of Panama. In his lifetime, the great frontiers were the oceans, and a historian later said he lived by the sea, died on it, and was buried in it. Well, today, we can say of the Challenger crew, their dedication was, like Drake's, complete. The crew of the Space Shuttle Challenger honored us for the manner in which they lived their lives. We will never forget them, nor the last time we saw them this morning as they prepared for their journey and waved goodbye and slipped the surly bonds of earth to touch the face of God. Thank you.
That speech never fails to make me emotional. And again, listen, I don't expect you to be a huge fan of Ronald Reagan if you're not. I know a lot of people don't like him. But in that moment, he, I think, hit all the right notes. Whoever wrote that speech wrote a brilliant speech that was delivered perfectly, I thought, in that moment. So anyway, let's continue on.
It's concluded that the space shuttles are being pushed too hard, and the concerns of engineers working on the crafts are being ignored or overlooked. What it came down to was that NASA had been trying to accomplish too much with too little funding. The investigation also determines that the two rubber O-rings which led to the fuel leak in the right booster and eventual catastrophic explosion of the external fuel tank were compromised by the severe cold from the night before the launch. Unfortunately, even if the crew had been aware of the problem at liftoff, there would have been no way for them to avoid the disastrous consequences. The space shuttle wouldn't have been able to survive a high-speed separation, even if it was attempted before the external fuel tank exploded. On June 6, the report is given to the President, who determines Marshall Space Flight Center in Huntsville, Alabama, Morton Thiokol Inc., and NASA as a whole are responsible for the Challenger disaster. Marshall Space Flight Center constructed the shuttle boosters, engines, and tank, while Morton Thiokol manufactured and built the booster motors. It's also uncovered during the investigation from several engineers who testify that they expressed concerns specifically about the O-rings and their seals to their supervisors for at least 2 years prior to the loss of the Challenger.
Yeah, and this is one of those things where there are all kinds of instances where people express concerns about something, but we never hear about it because that thing never goes wrong. But when it goes wrong, suddenly you've got a paper trail and you're like, oh my gosh, people have been warning us about this thing for years.
Hunters Commission recommends that communication between engineers and NASA management be tightened, quality control procedures be improved, and several more checkpoints be added to the Shuttle Safety Advisory Panel. On September 29, 1988, the Space Shuttle Discovery launches with 5 veteran astronauts on board. This is the first mission since the Challenger disaster. The Space Shuttle program lasts for 23 more years. On July 8, 2011, Atlantis launches from Cape Canaveral. It will be the 135th Space Shuttle mission. Atlantis lands on July 21, 2011, marking the official end of the Space Shuttle era. 2 space shuttles were lost during the 30 years that they were in use. On February 1, 2003, Space Shuttle Columbia disintegrated as it re-entered the atmosphere. And on January 28, 1986, Challenger exploded due to a faulty O-ring. Both crafts had a crew of 7, all of which were lost, and all of which were heroes. Now watch Atomic Bombing.
Yeah, so there you have it, the story of the Shuttle Challenger and what happened. And I would encourage you, there's a fascinating thing that you can do with some of these events that have happened over the last 60 or 70 years, which is to go back and watch the news reports as they unfolded from that day. You know, some of you guys are too young to remember 9/11. I would encourage you, on September 11th, if you want to know what it was like to experience it that day, watch one of the streams where they show kind of the minute-by-minute unfolding as you're watching TV and experience it through the eyes of those of us who experienced it on TV in real time. It's just an interesting way to look at history. So I want to say thanks for watching, and we'll see you again soon.